All right, day 2. Welcome back to the stream, everybody. I need to commit this before I do that. That as a feature. So I'll probably just copy day 1 into day 2. That seems to make the most sense. Hey, Nikki. Hey, I enjoyed your stream earlier. Thanks for doing that. Get rid of this. Let's get into here. I will not be updating VS Code. Sorry. Okay, so we have, let's get rid of the dat heap. Get rid of input to part 1's probably going to be very similar. We're probably just going to read in another one. So I'll just kill this for a second. I think what I want to do actually is do lib.rs. And then each of the bins can just be like, read it in and call the function. Or something, I don't know. We'll figure it out. Sub function, part 1. See what the problem is. Thanks for catching that syntax error on stream. It's probably too nervous to properly thank you, so thank you. Oh yeah, of course. I do that all the time. I was doing that yesterday on stream. So always happy to help. And it is not an uncommon thing to have happen. Okay, now you need to figure out how to pilot this thing. Wait, we don't know how to pilot this thing? We're already in the sub. Okay. Seems like the submarine can take a series of commands like forward 1 down to up 3. Forward increases the horizontal position by X units. Down increases the depth by X units. Up decreases the depth by X units. So we just have X and Y. Up and down, forward and back. Hopefully. Note that since you're on a submarine, down and up affect your depth, and so they have the opposite result of what you might expect. I don't like that at all. Can you just can you please just tell me down goes down and up goes up? I would really prefer down going down and up going up. What's your suggested resource for Rust 101 for an experienced JavaScript developer? I make a bunch of workshops at rustadventure.dev that are meant exactly for that. So there's a number of workshops, CLIs, games, serverless functions, stuff like that. There's a CDK and DynamoDB and AWS Lambda course coming now soon. There is a planet scale and Netlify functions with Rust workshop right now. There's 2048 with Bevy ECS at the moment. So this is my suggested path because I made it and it's for that. The other options you have are to like read the Rust book. So the Rust book is a free online resource. It's really more of like a language reference than it is like a path to Rust expertise kind of thing. At least in my opinion. I think that the But like if you need to go look up like how to do functions, you can click on the functions chapter, go check out functions, that kind of thing. But it's less of a storyline than other things. And some people don't like to read. So that's why I made a bunch of videos. There's also like a bajillion Rust books out in the ecosystem. So if you have any particular like Bevy engine, if you went to like a particular library or something like that, Bevy has a book. Many projects have books. They will take you through like the getting started, the next steps, the what is this, the how to use it, all of that kind of stuff. So also great ideas. There's a number of hard copy books that came out this year, but most of them are more targeted towards people who have already been writing Rust for a while. Like Rust for Rustations is very good. For Rustations. But it is also not meant for like Rust beginners. So there's that trade-off, right? Like if you want to just jump into the deep end, this is all Rust for Rustations is a great book. If you're looking for beginner material, Rust programming language is online, it's free. It covers the modern language. Rustlings is also a great option. Rustlings is a set of like exercises or cones or what have you. You can just basically download this CLI and then go through all the exercises. Yeah, so there's a lot of options for you. Down and up affect your depth, and so they have the opposite result of what you might expect. Yeah, okay. Already has a planned in course, your puzzle input, you should probably figure out where it's going. Forward 5, down 5, forward, whatever. Okay, cool. Horizontal position and depth both start at 0. The steps above would modify them as follows. Forward 5 adds 5 to your horizontal position, total of 5. Down 5 adds 5 to your depth, resulting in a value of 5. So we've just flipped the x-axis so that positive y is down, I suppose. It only shows positive values here, even though there is up and down. I'm not gonna lean on the fact that that's all we have, positive values. Input, this is our input. So we read the string, input.text. We unwrap because if we can't get input.text, we just want to fail. I could make that nicer. I'm probably not going to. This is probably not something we need to call at the moment. So yeah, I'm thinking that we want to do buffered lines for this later, but I think I'm going to do that as an optimization. I'm just going to read everything and parse everything to start with, because it'll result in a little bit simpler code. And I'm a huge believer in writing the simple stuff that works, and then when you need to, doing performance work, taking things from owned to references, taking things from many allocations to fewer. What do you get if you multiply your final horizontal position by your final depth? Okay, so should we do it like this? Struct submarine x I32 y I32. So we want integers. We're going to do 32-bit signed integers, so we can go negative. Total? Did I? Oh. You made me think I misspelled something already. Let's get rid of this for a second. So file fs read to string, input string, unwrap. We could just split this. We should just do an enum. Enum direction forward I32 up I32 down I32. Is there there's no backwards, is there? There's no like position. I guess position is going to be part 2. You're good. I misspelled something. Let's see. I do have my coffee today. Oh, that's what you know what? Every time I stream, I forget to tell people I'm streaming. So I appreciate all of you that showed up for the unannounced stream. There we go. Also, check this out. Ready? Take a bolt of waves. We got a little comment highlighter now. So if y'all have, oh, you know what? I should have done that for the Rust question. I'm slipping. You got me slipping. Okay, so forward 5, down 5, forward 8. So we're only adding to the horizontal position. We don't have like a direction yet, like a backwards. So we'll do that. We'll do file.lines. Fold. I forget if fold or reduce is the one with the initial state. So I'm going to impl default here. Oh, I'm going to impl default here. I'm going to derive default here. I forgot how much streaming just like messes with your head. Like simple things, like very basic things are just like, what am I doing? Cargo, let's just run. Cargo run in part 1. Expected closure that takes 2 arguments. So this is what the accumulator and the item, we'll call it. This has to return the accumulator. And then this will just do nothing at the moment. So let final position equal file.lines.fold, submarine default. Default for integers is 0. I already know that. So we're going to get a submarine at position 0, 0. Impl default is really nice. I really appreciate the fact that Rust provides a trait that lets you provide default characteristics to a struct or something like that. So if you need to construct one and it has valid 0 values, you can impl default. If it doesn't have valid 0 values, like you can't initialize it without setting things, then don't implement it. And you can write whatever new function you want. Okay, so there's this. Let's do mute accumulator. Item.split. Can we split on a character? I'm assuming we can. I should just use nom here. We'll do that later. We'll do it as an optimization. I have like a rock in my sock. Okay. Item.split. What does split return? Is split an iterator? I can probably just figure that out. Let things equals this. Turn my inlays on. if Rust Analyzer wants to. But split car. I don't really want to collect this into a vec, but I'm going to for the moment. So we'll do match items 0. This is going to be a little bit awkward because I don't have the enum implemented yet. It's fine, but I do want to do nom because that'll clean this up a lot. I just want to show like the basic way to do it, like the split, and then we can move into something a little bit more complicated that cleans up this code a bunch. To act dot. Should we have like a function called forward? Let's just have a function called move. Well, so the thing that I'm thinking about right now is, should I do the abstraction because I feel like I'm going to need it, or should I not? And I'm just not going to do the abstraction. And then let magnitude equals items 1 dot parse 32. So we're using turbofish syntax. I'm just going to assume this works because if it doesn't work, we're in pretty big trouble anyway. I have so many errors. Let's do this. I'll have to move that in a second, but that's fine. Why is collect yelling at me? Method, not a field. Oh, I didn't call it. Does plus equals not exist there? Oh, right. That's actually plus equals magnitude. Pattern. Okay, so if we have anything else, we're going to panic because unhandled input I. So if there's anything that's not forward, up, or down, we're just going to fail because that means that we did something wrong because this is a structured problem with clean input. Ooh, totally forgot that enums could take a values last night. Yes. The fact that structs and enums together form like sum and product types is one of my favorite things about Rust. You can stick structs and enums together with data, and it's so nice to just have this thing that's like forward plus this amount, or forward plus this data. And yeah. Anyway, it's one of my favorite things about Rust. Oh, is panic a format thing? Yes. Yes, it is. I think that there were recent changes to panic to bring it in line in Rust 2020 with the formatting behavior of the other formatting things, but okay, so all of this we need to do up. Let's just do this up here because why do we need to do that 50 bajillion times? So up is going to be act.y. This is minus the magnitude. And then down is act.y plus magnitude. And then we just return the accumulator. Final position is not used. And then we can, debug out the final position. Oh, because I don't have debug implemented on this. That'll be fun. Actually, I'll implement like display or something on that. That'll be fun later. 1998 and 741. Oh wait. What's the actual thing we need to do? Impulse submarine. Finalize is what I'm going to call this. Function finalize takes a reference to self, returns an I32, returns self.x times self.y. Is that, I think that's what we're doing, right? So we can just finalize that now. And then allegedly this is our answer. Huzzah! 1 gold star. Okay. So let's review part 1 for a second, and then we'll move on to part 2. So what I did here is I built a struct called submarine. Submarine has 2 fields, X and Y. X and Y are I32s, which are assigned 32-bit integers. Integers are nice because we don't have integers in JavaScript or something like that. JavaScript is all floats, which is, rough. We derive default and debug. Debug is just something that you should probably derive on everything. Default is something that you have to make a decision about whether you want to derive or not. Sometimes default doesn't make sense. So think about whether you have a default value. But if you do implement default, then we get to use submarine : default, which is the function for the trait, which is really nice. We impl submarine to add some functions to a submarine. Basically, if we are going to like finalize the submarine and do the thing that we need to do to finish the problem, we have to have a submarine. We have to have the X and the Y. So I'm just going to impl submarine, self.x, self.y, multiple of them. Enum direction is something that I want to use. So I wrote it down here so that I would think about it later. Where I want to use it is like right in here. The way I just wrote this is kind of like simple Rust is the way that I would put it. It's like much simpler or much more like JavaScript or like something like that than you might expect, right? Like yes, we have default here. Yes, like we have to put mute in front of the accumulator so that we can actually mutate it. But this is really just like split, collect. We have like an array of 2 things. Parse one of them into an I32. If these strings match, then do a thing. If not, then we totally messed up. And then just return the value. Like this is fairly, I would say, standard code for a language that doesn't have enums, that doesn't have really good parsing support. That you might do this with regex in another language instead of doing split. But yeah, so I don't mean like simple as in easy. I don't mean simple as in like trivial or anything like that. I mean simple as in like it's probably what you expect. So instead of simple, it's probably what you would write if you had no experience with Rust, but you had experience with like JavaScript or Ruby or something like that. And because we impelled on submarine, this final position is a submarine when we return. So you can see that with the type inlay here. And then we finalize it to get the multiplication. Multiplication. I saw a TikTok that was somebody just saying multiplication until it didn't sound like a word anymore. So it's fold like reduce in JS. Rust has fold and reduce. So the thing that these are on is called an iterator. Iterator is a trait. It's the thing that powers for loops in Rust. It's the thing that powers map and everything else. So fold lets us initialize an accumulator and then gives us like the first value and the second value and the third value. And then we have reduce, which allows us to treat the accumulator as the first item in the iterator. So for fold, we get our initialized value and the first item for our first iteration. For reduce, we start with the first and the second item. So we have both. We have options. Choose which one works for your case. Based on your calculations, the plan course. So this is part 2. I think we'll do part 2, and then we'll go back and we'll optimize part 1. I think that's the way that I'm gonna work my solutions here. Based on your calculations, the plan course doesn't seem to make any sense. You find the submarine manual and you discover that the process is actually slightly more complicated. In addition to horizontal position and depth, you'll need to track a third value, aim. So a theoretical z-axis, I guess, which also starts at 0. The commands also mean something entirely different than you first thought. Down increases your aim by X units, up decreases your aim by X units, and forward does 2 things. Increases your horizontal position by X units, increases your depth by your aim multiplied by X. I'm gonna probably trip up on the wording of that, but we'll keep going. Note that since you're on a submarine, down and up do the opposite of what you might expect. Down means aiming in the pot. Why? That's still like, why do we need that to happen? Why can't we just match like what we would expect? Why do we need to randomly flip up and down? Now the above example does something different. Forward 5 adds 5 for a total of 5. So I'm just going to start out by copying the other stuff that we have over here into part 2. I do kind of want to keep the dat stuff, so I'm gonna copy it down here and then move stuff around a little bit. You know what I should do if we have enough time later? I should do a cargo generate template that has just like dat in part 1 and part 2 and a library function. I think it's a joystick thing, pull back and you go up. I mean, like, I get it, Jacob, right? Like, I get it. But, like, we're not actually driving a submarine, is the way that I'm going to put it. Like, this is a math problem that is on an XY axis, and treating down as up is not something that contributes to the problem, in my opinion. There is one more thing we need to do here for the cargo toml, which I need to grab. Let's go up a directory, actually. I'm going to close this out. Cargo toml, dat, and profile release, and we don't need iter tools. Oh, I already did that. Never mind. I copied the whole thing. I forgot I copied the thing. So, in our submarine, we're also going to have aim, which is probably also going to be an I-32. So based on your calculations, the plan course doesn't seem to make any sense. You find the submarine manual and discover the process is actually slightly more complicated. So down X increases your aim by X units. So down increases aim by X units. Up X decreases your aim by X units. So these are both operating on aim now. Forward X increases horizontal position by X units, and then increases depth by aim multiplied by X. So let's start with increases horizontal position by X units. Already do that. Increases depth by your aim multiplied by X. So act.aim times magnitude, and this is act.y plus equals that. I have a really good idea for doing this later when we refactor a little bit. Let's see. Flip the coordinates like you did in 2048. So down equals down and it does the flip internally. Yeah. I mean, I have opinions. What can I say, Jacob? Definitely think some of the wording could be better. I got tripped up on Q1 part 2. You mean day 1? By wording the example and then realized it was way simpler than I was thinking. Yeah, I feel like a lot of the advent of code stuff like almost tries to trick you with the wording. And I don't love that because I'm not here to solve word problems. I'm here to practice programming. And I totally get that specs are written this way sometimes and things like that and whatnot. But okay, so I wish this was just a list so I could test it. Should we just run it and see if it works? What are the chances that just by making 2 changes, it just works? Huzzah, we're done. We're not done. We're going to refactor, but problem 1 solved, problem 2 solved. So it was just a couple of logic changes for all of the ups and the downs and the figuring stuff out things. Okay. Let's go back to part 1. Yeah, for day 1, for whatever reason, I think of those questions with parts instead of days with questions. Yeah, totally. I mean, I knew what you meant. I just clarified. I think what we're going to do here is we're going to start using nom, and we're going to parse into enums, which I absolutely love doing. And then what else are we going to do here? Yeah, nom to parse into enums, which will make this a match on enums. We should probably dat this before we do that and see what it impacts. Again, I don't really feel like the runtime is really interesting here, so maybe we don't do criterion today and we stick with that. So dat allocator, standard FS. And then the thing here. So I'm just dropping in the dat stuff. So we can now compile with release. So cargo build release features dat. And then I want to target release part 1. And I'm going to copy this. Well, first of all, I think I'm going to commit this. How long did that take us, by the way? 40 minutes? We'll round up. Yes, do that. I know, it's hilarious to me too. Let's stick a README file in here. Not outside, inside. Okay. So this is part 1 dat pre-refactor. I'm gonna name this stuff. All right. I shouldn't name it stuff. Advent of code day 2. Let's do part 2 for the dat stuff too, just so we have that before I forget. So this is going to be part 2 dat. All right. Maybe we shouldn't keep dat heap.json in here, because we're never going to know which one we ran. Okay, so if anybody's interested, the repo now has the code. If you feel like following along or doing anything, you're more than welcome to. So let's build with that. Well, we don't need to build with that. We need to start working on our new stuff. So I would like to change this. The split feels very funky to me. It doesn't feel very rusty. It doesn't feel very, like, we're not really handling any errors. We kind of defer our errors to like the parsing, and then like we don't know here if we actually covered the entire input. So I want to try to do that. And then the other thing that I want to try to do is do all of this incrementally, because we can just read the whole thing down the line and we don't actually have to keep it in memory. So I think that's going to have a larger impact on our total. Interestingly, both of these allocate the same amount of heap. I guess because we don't really do anything that different between them. So let's start with doing a read line by line in, which I forget exactly how to do. So Rust, read file by lines. I don't want to use dot lines, right? I want to use a buff reader. I want to use like a buffered read on the file. So we are looking for read lines, and then we consume it. And this is just, why is this in two different examples? Okay, so here we're going to drop this in. This is going to be file name. We're not going to read to string. We are going to pull in file, so standard FS file. We are going to pull in IO. We're going to unwrap this because we don't have error handling at the moment. We are going to not return OK here because that's not something that we're doing. And this overall is the thing that we need to do here. And then method not found in buff reader file. So we didn't pull in a trait is what I'm thinking. Let's go check the imports here. Let's pull this in. I don't know why Rust Analyzer suddenly stopped merging my imports, but I find it a little bit awkward because I do want those to merge most of the time. Method cannot be called on a result string IO error split. So our item, so when we do read, I assume we get the chance to handle every, yeah, okay, so we get the chance to handle every error or every line as a potential error. So we are going to completely bail out of that at the moment. I guess that's the wrong thing. Did I read the message wrong? Item.split cannot be called on result string IO error, which makes sense, right? So if we unwrap the item, then we should have a string. Oh, temporary freed while still in use. That makes sense. We're just going to call it unwrapped. Or it's going to be Spotify unwrapped. Unwrapped equals this. Does everybody know what a temporary is? More meetings. We'll catch the rest of the VOD later. Good luck. Appreciate it. Can't ever hear the term before I forget. Not think of that Slipknot song. That's awesome. I'm gonna have to listen to that later. So this will do the logic of the fill for a single line before it even starts reading the next line in the file. Yeah, basically we're going to read this in, and yes, it will accumulate into the submarine, but it will not pull the whole file in. At least that is my intended behavior. Whether I wrote it correctly or not is a completely different story. So we're actually allocating more by doing this. Buffer lines fold, unit accumulator. Is that because item is a string? Let's take a look at the... When I get temporary error, I make intermediary variables. That usually fixes it. Yep, that's exactly what you should be doing. Do I still have the DAT viewer up? No, I don't. DAT Rust. Online version. That's what we want. Let me grab the file, heap.json. That didn't work. That's not what I meant to do. All right, so let's check out what's going on here. Total 2 blocks allocated at too insignificant, too furious. Okay, so 6,000 nanoseconds, 96,000 bytes in 3,000 blocks. We keep 8,000 in memory. I wonder. Let me check the README again. Let's look at what we have here. We have 7,002 blocks. So I think allocating that extra string is actually hurting us. Okay, allocate. You know what? I think we should start doing criterion for these, because if we change the heap and we don't check the runtime, then we can have an effect where we grow the heap, but the runtime gets faster. This is also not a very large file, so I'm not even sure that matters. TG max was 6,000 here. I didn't check the other one. I should have pulled this up before we did that. Dropped the JSON file in. So this is vec allocation from collect from iterator.rs on 33. So at 33, final position, I guess fold calls collect. Yeah, the speed memory usage trade-off is real. Yeah, for sure. Part 1 main closure, fold calls collect under the hood. Why are we allocating a vec though? I wonder if I write a for loop if this gets smaller. What's the example they use here? They use a for loop here. Buff read, reline, lines, iterator fold. So total is 8,000, but the max is 10 bytes. Max is 64 bytes. So I guess actually we end up using more of the heap total. But really what I should have done is checked the JSON file for the other one before I made these changes. So let's do that quickly. I'm going to do stash. I'm going to stash this. Part 1. We will load our JSON. I think our program runtime doubled too. So I think actually read to string and the Rust compiler already knows what to do here. Interestingly enough. Because look at how small this is. This is one giant allocation. For the fold. And this one, so the revised version is 2 allocations. So this is still 80,000 bytes. This is 87. And this is just 80,000. Where does the extra 96,000 bytes come from? Is a question I have. Like there's 80,000 here, and there's 87, 83 here, right? In the first one, there's 80,000 here. But it says 87, 726. I wonder, because it doesn't allocate the string here, right? Am I reading this right? It doesn't actually allocate the string in the naive approach. So we tried to optimize it. We changed to a reader, but it wasn't allocating the string anyway. So what we did is probably less efficient than what the compiler did, is what I'm getting here. The 2 insignificant ones, but the insignificant, it's 2 blocks, 0.1%. Maybe the 2 blocks. Significance threshold, the total needs to be greater than or equal to 20 blocks. So possibly. There's the insignificant thing here too, though. See, this is doing standard IO append to string. And this is doing just the vec allocation. Let's do a for loop and see what happens. Let's do a for loop with lines.fold. Okay, is it more interesting to y'all to do a nom parser here to get the forward and the magnitude? Or do you think it's more interesting for y'all to keep trying to do dat stuff? I'll leave it up to y'all. Because the parser will let us change this code. I think we should do the parser. The dat stuff doesn't seem to be leading us in a very interesting direction. The changes aren't very big. And we can just run this again anyway. So we are splitting collect here. And I think that getting rid of this collect is probably helpful. Because we are instantiating a new vec for every line. So getting rid of that is probably worth more time than actually reading this in line by line. Because I don't think that reading this in line by line is nom, because I know nothing about it, and dat is still very magic-y to me. Yeah, okay. Let's do nom then. There was just a new major, not just a new major version, but there is a new major version of nom. So I'm just going to copy the example straight in. And we can do for direction, I think, is what we'll do. So I'll paste this down here. Cargo add nom. I don't think we need anything else. I do want to build this quickly because if we don't, then Rust Analyzer will just complain forever. Okay, so this is the parser. So let's do direction here, or move. Let's call it move, I guess. Maybe. I don't know. We'll find out. We're going to pass back a direction. We are going to... What are we going to do here? We're going to do opt. I don't think we need any of these extra helper functions here. We're going to do alt tag forward tag up tag down. And alt needs to be brought in, tag needs to be brought in. We're going to do bytes complete tag. I believe this needs to be a tuple. So because these can be different parsers, it has to be a heterogeneous type, which is what tuples are. So this will give us forward, up, or down. We could write an additional helper function here, actually, for that specifically. But okay, so basically what I'm doing here is I'm taking the input. So move is our parser. We're taking a string slice. iResult is a nom-specific result type that gives you the input type, the type that you're parsing into successfully, and then it kind of hides the error type from us. So we could define our own error type, but we aren't going to at the moment. But just know that there are three things defined in this type. There's the input type, which is a string slice. There is the thing that we are parsing into, which is the success return type. And then there is the error type. This is not what we need. This is not what we need. There's probably an I32 in nom. So let's go look for that. Yeah, let's just do I32. And then we're going to have to bring this in, and it's not going to be from standard, it's going to be from nom. Magnitude. I think we have to pull in iResult too. We don't have iResult in yet. Well, adding nom, add more to the heap stuff you were looking at earlier. It should reduce it. If we write it correctly. What are the alt and tag functions? My knowledge of nom is literally, it's a parser. You know what? I got to get in the habit of highlighting these. What are what are the alt and tag functions? So nom is a parser combinator library. This means that what we have is a bunch of functions that we can combine to build a larger parser. So in this case, when we say tag here, switch over. When we say tag here, we're looking for the string forward in the input. And what alt does is it says there can be one of these. So it can be forward, it can be up, or it can be down. And alt takes basically a selection of potential parser combinators. So in this case, it's just one of three tags, but it could be any number of things. and then we pass the input. So this constructs for us another parser combinator, basically. It is the parser combinator that will parse one of tag forward or tag upward or down. And we apply that to the input. So we pass the input in as a function, as an argument. And this will either succeed or fail, which we're handling with the question mark. The question mark will return through this iResult type. It's the same kind of thing that you would expect in any other question mark usage. In which case, we also have the input and some stuff we're ignoring. Actually, we're ignoring that right now, right? We'll call that dir to pull out. So what we get back from these parser combinators is the rest of the input and the value we parsed out. So we take, each time we're doing this, we're shadowing the input variable. It's just kind of a convention to do this because you have to write it a bunch. So this is the full input right at the top. We pass the full input to this parser combinator. This parser combinator gives us the rest of the input and whatever it successfully parsed out, which we can then use to do something like this. So we're basically, it's going to be forward space, whatever, right? So I'm going to try to tag a space and I'm going to pass in the rest of the input. And that will give us the rest of the input and whatever it parsed out. In this case, it's a space, so we're not actually going to use it. Which we can then pass the rest of the input into our I32 parser, which will give us the rest of the input, and then the thing it parsed out. So all said and done here, we should probably write a parser for the direction on its own. So let's do that. Fn direction, input, and string. Return type is an iResult that takes a string slice and returns a direct, or not a direction, I guess, right? We can't parse this alone because we have data. We're not going to do that. I'm going to back up. Because the enum has data, we have to parse it with the rest of the stuff. Because we can't do like the name of the variant without anything else. There's no reason to pull that out. So what we have here now is the dir, which is the direction, forward, up, down, and the magnitude. So if we match on dir, and we get like forward, up, or down. So you can see that this is basically the exact same stuff that we wrote up here. Forward, up, down. But in this case, we're going to do direction, forward, magnitude. And instead of doing this down here, or let's call this result. And let's return result here. So you'll see that the function signature for all of these parser combinators is rest of input thing, right? So when we write our parser combinator, because move is yet another one, it's just one that composes like all of the others, we have to return the rest of the input and the result. And then we could do a number of things here. Let's see if nom has any error stuff yet. So in nom 5 and nom 6, dealing with custom errors was a little bit. Oh, it was a lot annoying. Let's go check out what the nom 7 error management stuff looks like. I don't really want to define my own error type, even though that's usually what you end up doing here. Example usage. This is a custom error. Nom locate and nom supreme are also very interesting crates. I think we'll cover those later. Nom supreme is really interesting. It allows you to keep so nom supreme allows you to keep everything that happens and errors from the entire tree of parsing. So it gives you a lot more information. And then nom locate gives you like the point in the document at which you had got an error or got a value, which they call a span. So both very interesting, cool things, but I think we're going to keep it simple today. I think we're just going to unwrap this or whatever. Not unwrap. If I was trying to write production level code here, I would make sure that this came back as an error that I could handle. Why is move complaining? Oh, because move is a keyword, right? We can't use move. What do we call this? I'm just gonna call it parse direction. It's kind of not how everybody like you don't see this as being parse tag or this as being parse alt. It's just tag and alt. So people usually go that way, but we can do parse direction. So in here we can do parse direction item. And I'm just going to unwrap this. We're going to throw away the input and just take the direction. So now we know we have a direction which gives us all of the magnitudes and everything. Have hen do the thing. Yeah, nom is super powerful. I think it's far more understandable than doing parsing in other ways. Like if you start looking at ASTs and you start looking at like how people are like, hey, this is how we do a compiler and whatnot, you'll start hearing about like Lex and Yak and like all of that kind of stuff. And that gets like super, I don't know, it's like super in-depth and confusing and like not where I would suggest people start with parsing in ASTs. Parser combinators to me, they are functions that return like things you can compose, right? So like when you have a function that parses something, it returns you a value and you can compose that with other functions to parse more complicated values. So for example, the nom docs start off with a hex color, basically, right? Like hash FF AABB kind of thing. And there's a tag, and you compose tag, and you compose this hex primary function. And these are all just functions that take string slices and return like whether they successfully parsed the value that they wanted to or not. So you get to write like regular functions, and you get to compose those functions together, which is basically what we do in programming all the time anyway. And that gives you these like really high level parsers that give you rich structs and things like that. So we can match dir here now. And this will be forward magnitude, up magnitude, If I could type. The number of times I say, like, if I could type this when I'm live streaming is so high. Maybe I should do some typing practice. Okay, so we've got direction forward now, direction up, and direction down. And this is not something we need. So that cleans up our code quite a bit. Because now we don't have to do this split thing up here. We don't have to do any of the other stuff. Let's build this and run it. And there we go. So 1480518. What was our answer for part 1? 1480518. So we're good. So not only are we good, but we brought down our total usage to 7,000 bytes. Like we were doing DAT before, right? We were looking at 80,000 bytes, and we were like, okay, maybe if we do it like line by line or something like that. But that didn't do much for us because the Rust compiler was already smart enough to realize what we were doing and basically do a better job than we were able to. But if we bring up the viewer for our new iteration here, and we look at the heap, we see that this is not only taking much shorter, so it's taking 161 nanoseconds, whereas the other two took what? 6,000 and 3,000, which, to be fair and be perfectly transparent, DAT is not a runtime execution profiling tool. It's not. We would be using Criterion for that. We should be using something else, a different tool for that. So it's really just like context, right? It's not, hey, this runs faster or slower. It's just context. But we can see now that we have a total of 7,000 bytes. So we got rid of the allocations for split, and that seemed to be the big problem for us in terms of allocations anyway. So we've got the 12 bytes for opening the file, right, for the read to string stuff. And then we've got 7,000 bytes for actually doing all of the work. Actually, is that true? 33 and 33. We don't allocate at all, actually. So nom makes it super easy if you're using the right types. To actually, we didn't allocate. Nom doesn't allocate anything here. It's a what is going to be the term for this? Is it zero copy? It's zero. Yeah. So I didn't mention this before, but the description of what nom actually is a parser combinatorial library with a focus on safe parsing, streaming patterns, and as much as possible, zero copy. And you can see that here. 1,000 bytes off with nom? No. 70,000 bytes off with nom. Or 90 if you want to look at this. So this is 87,726, and this is 7,726. So 80,000 bytes. It doesn't allocate anything because it uses references, Nikki. Like, the types we're using here, the string slices, we're passing around references to things that are already allocated. We don't do any allocation here. Right? So it's not like we're creating a capital S string, allocating more on the heap, returning this extra stuff. Like, we're passing in a string slice, we're returning a string slice, and the only thing that we're doing here is pointing to references in pieces of that string. Yeah, Nom is super impressive piece of software. Let me copy paste this into the README. Part 1 with Nom. So what else do we have here? Really the only thing... Oh, that's part 2. Really the only thing is like, instead of matching here, we could move this onto a function on the submarine. So instead of having this like this, we could have sub dot, we can't call it move. Sub dot, what's another word for move? Somebody give me another word for move. Swim. Our submarine swims. That's impressive. This is going to yell at me because I'm taking a mutable reference. Oh, let's just make this unit. We actually don't need to return this because it's muting. And this is sub. And then we return it. So now look at this, right? This still does the same thing. Build release. Part 1. 7726. We have changed nothing, effectively. Execute command. That's not bad either. Locomote. Y'all were too slow. I chose swim already. Our sub is a swimming sub. So, now all of our code is encapsulated into these like 5 lines, right? Or like the thing that we're doing is encapsulated into these 5 lines. We take the lines, we fold over the submarine. Let's get rid of the inlays here. Looks a little cleaner. We take the sub, we take the line. I guess we should call this line and not. We parse the direction out of the line. If we get one, we swim there. And then we have the sub. Alternatively, burr. I like that. You know what? If I use that, I'm going to forget how many R's there are. Rust will remind me, but it'll be a constant pain. But yeah, so like we just move this. We're moving the direction in here. We do nothing additionally on the heap. So yeah, I mean like Nom and Rust and trade implementations and things like that allow us to do a lot of like cleaner work here. And then like, so this is all basically the same stuff, right? So let's do this. Let's go parse direction. We'll pull it out. We'll put it into this library, right? I'm going to copy and paste all of the use stuff. We don't need FS here. We don't need dat here. Where is part one? We've got the submarine changes, so I'm going to leave it here. The direction does not change, so I'm going to pull it into the library. Right? And we need to make the use pub. And then this is use. What do I call this? What did I call the day to submarine? No, day to direction. It's not crate because the crate is the bin. I think I need to define the library. Day to direction. What did I do here? Oh, it's named day one. Oh no. No. Parse direction. We don't need nom here anymore. We do need that and whatever. So we've got our sub definition and what the sub should do in response to the things. We've got the main stuff. This could probably be pulled into. Has it really been 3 years since the pony advent of code streams? Yes. Yes, it has. Day-02 versus day_02 is confusing to me. The way that I would suggest you think about that is that crates cannot have dashes in their names. So it has to be an underscore. So the folder can have a dash and whatnot, and the package can be called a dash, but the thing when you go to use it has to be an underscore. The before times. Okay, so if we look in here, we can pull in the same stuff now that we have an actual. So parse direction and direction, we'll get rid of direction here because it's the same thing. Parse direction, we need to redefine the sub. So if we take this, right? And we have this submarine here and we add the swim, but we move our logic back in. So we're changing the implementation of the submarine, but we're using the same direction and the same parsing mechanics. Oh, that's not sub, that's self. And then I'll go down here and I'll take this final sub stuff. And I can just paste this right in here because it's the same exact thing. And now we've got this function, which we could use, right? We could define this in our library and just say, pass us a string of new lines and we'll deal with it. But I decided not to in this case. The only changes here are the magnitude. So if we build this and we run part 2, we get 7,726 bytes. So where's the README? So they're the same, but it is nice to confirm that they are indeed the same. So yeah, I hope that I've stoked your interest in Nom, because Nom is absolutely freaking amazing. It's reasonably easy to use. I will say, I will caveat that with if you're trying to fully enumerate your errors, you are going to have to put more work into learning what Nom does with those errors. You do have to map your result type into one that can be used in this iResult. This iResult is actually a 3-item type. So you, again, the string slice for the input, the output type, and the error type. The error type is not shown on screen here. You can put that in there, but that's the only caveat that I will have. I really love Nom. Nom is really great. It makes it really easy to write really performant, really low allocation like parsers. I have an MDX implementation using Nom that is, oh dang, it runs in nanoseconds. Is that 225,000 or is that 225 with zeros? Using the European dot instead of a comma. 225,000 is a lot. I haven't seen your solution, so I'll take a look at it later if you posted it. But yeah, at least you have a way to measure it now. That is really easy to use. And yeah, I don't know. I absolutely love the way that Rust comes together in the sum and the product types, which allows us to do these like structured operations, right? Like we know that we have one of these 3 now. We don't have to just be like, oh, is there like an extra string or did I misspell this? Like, no, like we parse it, it either parsed correctly or it didn't. And then we have from that point on just these enums with the data that they need. And then Nom is just like mind-blowingly awesome when it comes to actually parsing stuff. So yeah, I don't actually think there's anything else we can do here. The only thing that I could think of at this point, let's see, what are we doing here? Max 7,000 bytes. I wonder if we see a difference now if we go back and we do the read lines. Let's try that first before we end. I'm going to do it in part 1 because I don't think that there's a huge difference. Jeez, what am I doing here? I'm putting all sorts of things in all sorts of the wrong locations. We'll just unwrap this. I'm choosing to unwrap a lot in Advent of Code because I feel like the Failure mode here is I want to see the failure as soon as possible. And I want it to stop the application. And I'm not really handling anything, so. What did I do wrong? New file.lines. Oh, right. I need to pass file in here. I did the lazy way and parsed and processed separately, plus use Saturday. Definitely lots of little improvements to make. Yes, you can write like 0 copy Saturday deserializers. It is just much harder. The happy path for Saturday is definitely like serializing owned types. You can definitely do references in the same way that like Nom is doing the stuff here. I just find it significantly easier to parse 0 copy style with Nom than I do to write a deserializer with Saturday that is 0 copy. But people do it. It is possible. It is written in a way to make that possible explicitly. I'm going to try and learn use Nom this year too. Certain there'll be plenty of opportunities. Yeah. I mean, even today, right? Like you could just go try to write it from memory and play with it. Why is lines... Standard IO self buff read. So this is allocating for every string. So you see that doubles our total usage. It even increases our like TG max. So the maximum that we're using at any given time. So very clearly there is something here that I am not picking up on immediately. That the Rust compiler understands better than I do. Right? And for the small file, it may actually end up being like the fact that reading it in actually turns out to be less than reading it in line by line. See, that's 10 bytes in one block. See, interesting thing here though. We've got 12 bytes for the file open in the Nom version. We've got 7,714 bytes for the file, which I believe is the size of the input total. And then if we look at the version with the line reader, at any given time, the max that we're using is 10 bytes. This does result in more total bytes used, but it results in fewer bytes. Like this can run in like 20 byte memory or something like that, which is kind of ridiculous. But it does increase our total heap usage. So if our goal is to use as little heap as possible total, read to string works the best. Did it decrease the runtime? It increased the runtime. Again, DAT is not a DAT is not a performance tool, right? Like this is just contextual in the sense of like we hit maximum like allocation at a certain point in the runtime of our program, right? So what this is telling us is we hit the maximum, the highest amount of allocation 98% of the way through our program. It's not really giving us reliable information about the runtime of the program in a production environment, right? because the way that dat works is we're replacing the allocator, and every time we do an allocation, dat is tracking it, right? So we're doing extra work on every allocation because dat has to. And if we do more allocations, which is what we're doing between these two, right? That's the big difference between these two. We are doing either a bunch of small string allocations for the line by line pull in, or we're doing one giant allocation for the read to string version, right? So in one of those, that does work once, and in the other one, it does it n number of times for the number of lines that we have. So this runtime isn't really reliable, in my opinion, in terms of like how fast this would actually run without that. We would have to use like Criterion or like a benchmarking tool and not run with the data allocator to figure that out. Saturday was just reading the file, like copied the file to a JSON object, opened it with Saturday because I wanted to just write code I knew. Yeah, for sure. I mean, like, that's part of programming, right? Like at some point you just need to do the things that you know because you do need to get things done. And when it matters, you'll know. Is there some deallocating stuff that's missing? Would a for loop change it? Deallocating stuff that's missing. Are you saying that? What are you referring to for deallocation? Like in general, things get deallocated when they're dropped, right? More or less. Well, in the sense of like, I think that talking about when things specifically deallocate might not be the most useful, right? Because the actual behavior of Rust, as I understand it, is that, yes, you've said that we don't need these bytes anymore, and no, they are not safe to read anymore, but they still might be there, right? Yes, it is a Baby Yoda hat, Nikki. The total bytes thing with the buff reader. No, I think we're seeing the overhead of allocating. I don't know what the minimum string you can allocate is, actually. Let's see, we've got 1,000 blocks here, right? Average size, 8 bytes. Let's see, Rust smallest string. This person wrote a small string crate, which should give us some information. Oh, actually, that's Amos. Of course it's Amos. I don't know if they wrote this package, but I am so unsurprised to have landed on that blog post. So this small string crate will stack allocate strings if they're up to 22 bytes long, which fits our strings, actually. So maybe we play with this for a second. I think we have a second, right? Yeah, we've got about 20 minutes. Small string is immutable. I don't know how this will impact nom, is the thing that I'll say. Just wondering if there's something about fold that's telling Rust to keep things around with a buff reader versus a string. Oh, no. So the buff reader only keeps around about 10 bytes. right? At TG max, we're keeping 10 bytes. The total is 8,783 because that's the, I think, total that we've allocated, if I'm reading this correctly. We can definitely try this though and see what happens. I'm happy to. What is this? This is just that. So buff reader, new lines. So let's do 4 line in lines. Okay, so this is the for loop version. It has not substantially changed the amount we're allocating. And to be clear, the way that for loops are implemented in Rust is on top of iterators. So important to keep in mind that when we switch from iterators to for loops, we're not changing the underlying implementation. So we get the exact same thing. See, this is the one that this is the line reader one. It's interesting that we're getting append to string. Buff reader read line. Like we do have to put it in memory at some point, right? So we don't get lower than the file in terms of total memory. I think we are seeing growth because the lines are actually smaller than the smallest like capital S string can be. Cool, thanks for the test. It's definitely interesting that buff reader allocates so much more memory. Yes, and I do think that using something like small string could help with that. Right? Let's see. Let's actually try it, because I think we can. How do we get to small string? Small string. Small string. Good enough default storage for tokens of typical programming language. Strings consist of a series of new lines, followed by a series of white space, are a typical pattern because of indentation. Note that a specialized interner might be a better solution. Yeah, cool. So we have as str, which we will need for the nom stuff, which will mean that we don't have to actually change much. I do not know if we can read this file into this string type. Well, let's try it. Small string. Small string. File open for line. What is this saying it is? Result string error. I don't actually know if we're going to be able to get away with this. I love the memes just make it into Rust crates so regularly and it's just a thing. Yeah, for sure. Is empty, is car boundary, as bytes get unchecked. Slice unchecked, cars. There's lines here, which is interesting. Find car boundaries, gets. So he is using Serde, it looks like, to pull in files. Also tracing Alex. The Servo logo. Basically doing the same thing that we're doing, but with a different allocator. Alec. Amos writes very in-depth articles, so the actual code I'm looking for from reader unwrap. There's no reader thing in here, right? What's the state of Servo now? I don't actually know. Not the right person to ask. So buff read will read lines, but it doesn't look like we have. Reading line by line is inefficient without using a buffer, so if you want to read by line, you'll need buff read, which includes a read line method as well as a lines iterator. Yes. So does that mean we would need to implement buff read for what is the buff read type? Trait buff read requires read, implements these things. I feel like that's the way we would have to go. Lines self. Looking awful rusty in here. Hello, Xander. How are you? IO buff reader new. Lines. The buff reader adds buffering to any reader. Yes. Makes sense. This whole thing isn't within 22 bytes, though, the whole file. Only each line is. The default capacity is 8 kilobytes for a buff reader. So that's interesting. I wonder if we could change that. Doing well. How's everybody doing? Doing all right. Doing all right. We finished everything, so we're just kind of playing around now. I'm just gonna take another couple minutes, basically. Finish up around 12. But right now, what we're doing is kind of like micro optimization stuff, just kind of exploration, which is fun. Right now, what I'm trying to do is use an alternative string type to read lines in more efficiently. Well, that's why we get an extra 8 kilobytes. Do we get an extra 8 kilobytes? Is that what it was? Because it's, yeah. Average size 8.78 bytes. I think that we have varying input lines, right? Rust car is a U8, right? So car is a byte, which means that our input, where's our input? Input somewhere. So here we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 4, 6, and 9 in terms of bytes. I wonder if the issue is that if we don't have it set to, if we don't have our buff reader allocating 9 bytes, then that's where we get the extra. Because if we're doing 8, so if we're doing 8, right? We don't quite get 2 if down and up are next to each other. We split it in half, kind of. So I wonder what the most efficient method of doing that is. I bet you it's something like read the first character, figure out how many bytes you need exactly, and then read that. If you want to keep allocations as low as possible, I mean. Each line is only 10 bytes, but it still has to allocate the full 8 kilobytes just in case. Oh, did I say, is it kilobytes? It is kilobytes, isn't it? With a default buffer capacity. Oh, yeah, okay. So if that is that's the total file size, not the line size. What is inner? Inner is a reader, which is a file with capacity. Okay, so let's do with capacity. With capacity. What do we think? 9? U size. I hope this is in bytes. Yes, it's in bytes. So 9,000 is 9 kilobytes, right? That doesn't help though. Like, no matter what I do here, not 9,000, that's bigger, isn't it? Bigger than what? I thought we were at 8. 8 kilobytes is at 8,000 bytes, right? You want to make it smaller? I thought the buff reader was going to be for the whole thing, but maybe it's not. You're telling me that maybe we do like an extremely small number of bytes kind of thing? So we can reduce this. I don't know how to find the right number here. I feel like it would be a statistical analysis of the file itself. Because ideally we wouldn't want to just lock it to like our input. We would want it to do generic input, right? Anybody should be able to send their thing in here and it should work. This would have been a fun one to do as a serverless function. I think we'll do that maybe we'll do that tomorrow if it's acceptable. At 100, we're closer to read line speeds, which is kind of interesting. Yes, it is definitely interesting. At TG max, we're 1,000. So we have effectively done the thing that we wanted to do, right? We have both reduced the max memory usage at any given time, and we have brought down the total to something that kind of resembles the actual file, but is not exactly the actual file. So I don't think we get to the point where we match the file size exactly. I think we always have a little bit of overhead because of what you were just saying, Derek, which is like we have the buff reader and it allocates and it allocates and it allocates for the buff reader size. And when it does that and finishes, like there's still some left over, right? We're never going to be exact on that allocation. The max is 10 bytes in one block, though. So the total buffer size keeps 1,000 in memory, and we read in, it looks like 10 bytes at a time. So we have two levers to play with here. We have the amount that we're reading in each time, and we have the like amount of the buffer that is available to us. So what is the file size? File size was like 7726 or 7714. So let's do So if we do 8, and we run this, it doubles the total again, which is really interesting to me, because you would think that the buffer is just there, right? And we're just pushing stuff into this buffer, and we never push more than 8,000 bytes, right? Unless the alignment is off. So yeah, I don't know. There are numbers to play with. They do things. We've explored them a little bit. It's kind of time to stop the stream here, and we're kind of doing like micro optimization anyway. So that was fun. We got the both problems done in a very short amount of time, and then got to play with that again, which is really fun. I'm gonna be honest. Like, I really like seeing the numbers, even if it doesn't always like. Not work is the wrong thing. Even if it doesn't always like have a measurable impact or like a thing that I would want to do instead. So the total seems to be the allocation of the buffer plus the 8,000 byte runtime. The 8,000 byte runtime. I'm not sure what you mean by that. But we can talk about it in Discord. If you're still hanging out and you've been here the whole time, join Discord because you've been here. And that's it. I'm going to call the stream.